Hello and welcome back to another episode from Driving Britain. Today's episode is a reaction video to is the metric system actually better? Now in the US, the imperial system is used, inches, feet. In Europe, the metric system is used, millimetres, centimetres, kilometres. In the UK, we use both because we're complicated. So for miles per hour, for speed, rather than kilometres per hour, we will buy food by pounds of potatoes as well as kilos. Our measurements we do both in centimetres, millimetres, metres, as well as inches and feet. We measure distances in miles, not kilometres, and we weigh ourselves in stones and pounds, just to make sure that we confuse absolutely everybody. So which system is better and what's the reasons for sticking to just one, the other, or both? Now I know offhand that when we started to swap towards using metric, there were some incidents with aircraft. At least one aircraft from the UK, and I'm sure that there's probably others, but I know that one from the UK filled up thinking that he's putting in gallons, but he put in litres. So his measurements were quite far out and they went out of fuel. I'm sure that they did a safe landing, or they landed without death anyway. I'm not sure how safe, or if it involved a runway, but they did land. That bit I do remember. And I'm sure there's got to be other instances. So we're going to look at the videos, see what else they come up with, and see what their arguments are for and against. And then at the end, I want you to put in the comments your arguments for and against, and why you think that the system that you use in your country is best.
The time has finally arrived. The comment section demanding imperial and metric units has gone on too long. There can only be one measurement system. The British imperial system, like everything British, is based on antiquated units of measurement, like measuring your country's importance by counting the number of countries you have invaded and pillaged. A measurement that made sense.
Now come on, alright, the UK did go on a couple of gap years that, well, got a bit out of hand, but that's a bit harsh, isn't it?
100 years ago, but it's time to move on. Weirdly, the British have most.
Actually, talking of stuff like that, one thing that we do is nuts and bolts. We have both measurements. Most UK mechanics will have both measurements with their tool sets. So you might get something that's a 1/2 inch nut, or it might be a 13mm. Same for Allen keys and everything else. So we need tools to be able to deal with both sets. A lot of the new cars, they're going to be in metric, but there's a lot of the existing cars, and especially the older cars, where they're in imperial. But I mean, the old 3/16ths and stuff like that, how am I supposed to picture that in my mind? Do I mentally cut something into 16 pieces and then think about how big 3 of those are going to be? That's a bit much. I'd much rather just think about an actual amount, like 5mm or 30mm or whatever it works out to be. 9/16, isn't that a 19mm? Don't remember offhand. Somebody put it in the comments.
Mostly moved on from this method of measurement, and it is instead Americans who insist on holding onto it. Well, America, Liberia, and Myanmar, a prestigious trio. Now, I can already hear the people who refuse to wear masks in the comments. There are 2 kinds of countries, those that use the metric system and those that landed on the moon. You know who led the design team for the Saturn V? This guy. Listen to that deep Alabama accent.
This weight dictates the amount of fuel and the numbers of motors.
An American through and through. Ignore this photo of him. Those are just some German friends he made while on gap year in Europe. Look at all his friends. Let's count them.
Hey, that wasn't
1,
a gap year that I was talking
2,
about.
3, 4, 5, 6, 7, 8, 9.
Yeah, but in the same point, the US and the UK did manage to poach quite a lot of German scientists, top scientists, which then helped us develop stuff that we wouldn't have had a chance of developing without their help. So yeah, he might have had some shady friends, but the fact is he went on to help our countries.
9 friends. A popular man. This Alabama native used metric. In fact, he despised British units. So much so that he designed a rocket during his gap year to fly to England to show them how great the metric.
A German in that era not liking somebody from Britain? Well, that's a real surprise.
system was. The Saturn V was designed like nearly everything in NASA at the time, with a mixture of both metric and imperial units. Just read the mission reports for Apollo 11 for proof of this. It switches.
They just don't match up. They just won't work. That's what I was on about earlier with the toolkits. You know, if you've got a 1/2 inch bolt and you're trying to use a 13mm spanner on it, or vice versa, you're just going to end up taking the corners off nuts and stuff like that. And with Allen keys, it's even worse because you'll pull the corners off straight away. So a space program with them sort of levels of error, that's just a really bad idea.
Inches and centimeters constantly. It's a mess. Anyone working with this report would have had to be hyper aware of what unit of measurement they were using. Most of the design and science work was done in metric before being converted to imperial for the manufacturing and operational staff. One of the most mind-boggling examples of this is the guidance computer. It was coded in metric. Meters and
I do remember
kilograms
some problems with this. Yeah, I don't remember what they were, hopefully he's going to say, but I do remember there were some problems because the program was built on a British or European sort of basis, using our measurement systems or our calculations, and when it tried to be transferred through to the US, part of the program didn't work. I don't remember exactly what happened. I just remember that it was a big thing at the time. Well, obviously I don't remember it, but I mean I remember controversy about it, doing the rounds through the media and stuff.
The language of science. But to ensure the astronauts could intuitively understand what those calculations meant, the displays inside the lunar module had to be displayed in British imperial units. So,
because that's not going to add any level of confusion at all, is it?
When computer power was extremely limited, the engineers had to waste precious computational time and power to conversion.
Yeah, the entire computing power of that entire shuttle's probably less memory than what you'd use in a single text message nowadays.
This isn't just a waste of computation power. Errors in conversion have led to an insane number of accidents through the years, some of the most notable being in NASA. In December 1998, the Mars Climate Orbiter took off from Cape Canaveral aboard its Delta II rocket. Over the course of its 9.5-month journey, the orbiter needed to complete trajectory correction maneuvers to bring it into an optimal orbit insertion altitude of 226 kilometers. However, as the time grew closer, calculations showed that the orbiter was entering Mars orbit in a far lower altitude, so low that it was likely going to strike the atmosphere and violently tear itself apart. This is exactly what happened. So, what went wrong? The orbiter was coded with metric units, so the thruster control unit was working with the metric unit for impulse, Newton seconds, but the controller was being supplied with pound-force seconds, which differs by a conversion factor of 4.45. A massive discrepancy.
That's just stupid. How come that wasn't picked up at the beginning? Firstly, why were some of the most intelligent scientists on Earth doing one of the biggest projects on Earth using two systems that were blatantly never going to mesh together very well? There's always going to be errors. There's always going to be a margin of error when you're doing that. You're never going to be absolutely precise. Well, obviously it's impossible to be because they did it wrong. But also in the actual computing program, why wouldn't you have one unified system? That's just madness, that is. Doesn't matter which system you go with, you still stick with one, surely.
That destroyed a $328 million project. In 1983, an Air Canada flight departing from Montreal ran out of fuel halfway to its destination in Edmonton. Why? The ground crew knew 22,500 kilograms of fuel was needed for the flight.
I remember that there's problems with the UK flight, but I didn't know there was also a US flight, and it sounds like this one was a bit more catastrophic by the sounds of it.
They, however, needed to calculate how many litres were needed to be pumped. So, they used the density ratio to convert the weight measurement to a volume measurement, but they used the 1.77 density ratio, which was pounds per litre, instead of the correct ratio of 0.8 kilograms per litre, resulting in less than half the required fuel load being pumped aboard. Luckily, the pilot managed to glide the plane down to an abandoned airfield, but that little boo-boo of a conversion error could have resulted in a catastrophic loss of life.
Yeah, that wasn't the one that I was thinking of. The one that I was thinking of was over UK, Europe, somewhere, that sort of region. I'm sure it's flying south towards Europe. But the fact that means it's happened at least twice, plus the spacecraft. After one of these things happened, something should have been done, let alone three. And we're all still doing exactly the same thing. That just seems like a really bad idea.
These are two cautionary tales with disastrous consequences, but it tells you nothing of the silent screams into the void every engineer in the world lets out when they are forced to work with both units. It's just an unnecessary pain in the ass we could all do without. This is the reason we need to choose one measurement system. Mixing units not only is tempting fate with conversion errors, but it costs an untold number of hours for scientists and engineers around the world banging their head against tables, when they could be using that time for something more productive. I could end the video there, but we need to really hammer home why metric units are the superior units. So why is it better? Well, let's start with the fundamental unit of measurement. There are 7 base units of measurement, and with these 7, we can measure everything in the universe. Think of them like the 3 primary colors of light. With these 3 colors, we can create any color in the universe by mixing them in just the correct proportions. We can do the same with these fundamental units of measurement. They are time, length, mass, temperature, electric current, chemical amount, and luminous intensity. With these measures...
Yeah, that's a good point actually, which is not making, but springs to mind. It's only in these sorts of measurements that we do have different systems, isn't it? If you think of any other type of science, we stick to pretty much the same sort of system, whatever topic, whatever subject. It's only in measurements that we seem to be varying. If you think of currency, you still have 100 cents to the dollar, don't you? Just same as we have 100 pence to a pound. So I wonder why measurements were left out of the race.
We can describe our universe. Velocity is a combination of length and time. Volume is length cubed, density is volume combined with mass. These measurements are the language of the universe. So, let's see how the imperial system handles a very simple one, length. An inch is a standard unit of measurement for length in the imperial.
Yeah, if we was going to cut a piece of wood, if it worked out to be, say, 5 inches, then we would go by the inches. If it worked out that it was in between main numbers, then we'd go with millimetres, centimetres and millimetres. If we wanted to be really precise, then we'd use centimetres and millimetres. We'd only use inches for kind of rough guide, unless it happened to fall pretty much directly on the inch. It doesn't happen very often.
Real system. Let's imagine a scenario. You are designing a railing for a 1 mile long bridge. You, as a skilled and knowledgeable engineer, know that 2 half-inch bolts are more than enough to secure the railing down. The posts of the railing are 6 feet apart. Alright, how many inches are there in a foot? 12? So that's 72 inches. Every 72 inches we need 2 bolts. Our bridge is 1 mile long. How many feet is that? I don't know off the top of my head, and a quick Google search tells me it's 5,280 feet. What's 12 inches by 5,080? That's 63,360 inches. Divide that by 72, that's 880. So we need to order 1,760 half-inch bolts. That felt cumbersome. Why do I need to remember all these numbers? Because imperial is a convoluted mess of measurement units invented by people who married their cousins. That's why. Now, let's see how much easier that is in metric. How many millimeters are there in a meter? It's in the name.
But it's not wrong though, is it?
1,000. Now, how many meters are there in a kilometer? Once again, it's in the damn name, kilo 1,000. Given a measurement in kilometers but want meters, just shift the decimal place over 3 places. No calculation needed. There is no room for error.
Yeah,
it's a simply
well,
better
that's
system.
like with money, isn't it? That's what I was on about with money. If you want to work in tens or hundreds or thousands with money, then you do exactly that. You just move the decimal across. And that's what you do with measurements in metric. So I think that alone kind of shows money is important. So we want to make sure we're absolutely precise with it. And we use almost the equivalent in them sort of terms as the metric type of system, don't we? We use tens and 100s and things. So it indicates that it might be the more precise system.
Even within imperial, you have to constantly convert your units. Ounces to pounds, pounds to imperial tons, which for some reason differs from a metric ton by 1.6%. Again, in metric, there are 1,000 grams in a kilogram and 1,000 kilograms in a ton. In imperial, there are 16 ounces in a pound and 2,240 pounds in an imperial ton. Why? You aren't even following the same conversion conventions as your other units. This is insanely cumbersome. The chances of conversion errors even within your own damn system is high, never mind having to convert to metric. You know what's even more insane? The word for mass and weight in the imperial system is the same. Why? Because the pound was invented before we knew what gravity was. That's why. We just assumed mass and weight were the same thing, when they aren't. So we have to specify in imperial whether we mean pound mass or pound force. I haven't been this confused since I watched Magic Mike. The most ridiculous thing about all of this, every single one of these imperial measurements are legally defined by the metric system. America is already using the metric system, and most of the population is oblivious to it. Freedom, America, guns, pew pew, hoorah. The foot is legally defined.
Yeah, exactly. That's what I was trying to get at earlier. Your currency, you use units of 10, a pound, a dollar, 10 cents, 1,000 and so on. But also, like you said, with weapons, you'd have a 9mm. Maybe that's just because you was getting the ammo from European countries, and so then it was just coming over in millimeters. But yeah, all of your... I know that there's some odd-sized ammo that comes under a bit different, but generally you do go in millimeters with quite a lot of stuff, don't you, I think? Not as much as the UK. But when they first changed or tried to change us from pounds into, or from imperial through to metric, they were forcing these shops to start advertising weights in kilos, rather than, if you buy a bag of potatoes, it used to be £56. But then they started trying to make it out into kilos, and they even the government started to go to the extent of finding shops if they weren't putting the new metric measurement on there, because shops just refused to and wanted to stick to their old systems. But what did happen when we did finally kind of all get mostly converted over, or as much as we ever have, then a lot of people rounded things up, a lot of shopkeepers and stuff like that. So they were kind of giving you, rounded them down more, so they're giving you less product for the same or more money, using the conversion as a way to diddle the customer, basically. Just like when we went through decimalisation with money, when it changed from old money through to the decimalised money, when we went through the conversion, prices suddenly took a massive jump. It's one of them things that happens throughout history, I think.
As 0.3048 meters, the pound is legally defined by 0.435 kilograms. Why? Because the metric system is run by the International Bureau of Weights and Measures, a neutral international organization whose sole mission is to create a global language of science.
Yeah, how are you going to do that
America
with imperial?
Is a member of, and they have succeeded in an awe-inspiring way. In 2019, the final metric base unit, the kilogram, stopped being defined by human artifacts and is now, like all other metric units, defined by the laws of physics. In 2019, it ceased being defined by this hunk of metal.
Yeah, but you're not going to be able to do that with imperial, though, are you? Because I know that they've done this, to get it unified, and I remember it being kind of announced that they was doing it and that they'd achieved it and everything. But I don't think you can do that with the imperial, can you?
Began being defined by Planck's constant, which is defined as 6.626 by 10 to the minus 34 kilogram meter squared per second. Of course, to use this as a definition, we need ways to define the meter and second. The meter is defined as the length of the path travelled by light in a vacuum in 1 divided by 299,792,458 of a second. Okay,
well, that just rolls
so
off the
how
tongue,
do we
doesn't
define
it?
a second? A second is defined by the hyperfine transition frequency, which is the frequency of radiation which will cause an electron to jump from two closely spaced low energy states in a cesium-133 atom. Each of the base units are defined like this, using the unchanging language of the universe as its yardstick, or should I say, meter stick. It's a beautiful and inspiring language that transcends the realm of humans, and for that reason alone, you should strive to use the metric system. Understanding the language of the universe is a superpower, and there is no better place to become fluent in that language than Brilliant. Did you know that you can...
Okay, I think he's at the end of the part of the video that we want to look at. Yeah, I'm sure that because it was on about that the measurements don't quite add up, you getting errors in it, then does that mean that you wouldn't be able to even make a weight using the same principles as what they've done for the metric system? Is he saying that it's literally impossible to do, or that it's just going to have potential errors with it? If you understand a little bit more about how they produce those weights and what the error margins are, then add it to the comments. But generally speaking, I think that in the US, you do use both, whether you kind of realise it or not, because of things like the 9mm for your ammo and that sort of stuff. You also have to incorporate similar sort of systems with your money because you're working in units of tens and so on, which is pretty much the essence of millimetres and metres. But they're also a lot easier to work out because you do just shift the decimal up and down depending on what you need. If you measure something in millimetres and then you want to transfer it through to centimetres or metres, then you just need to shift the decimal around. Whereas if you're going to try and do that with inches, you're going to end up with just a whole mess, aren't you? But also, like I say, when we're making measurements, say cutting a piece of wood, then we would use inches for rough guides. I want a piece of wood about 6 inches wide or something like that. Wouldn't really, if it didn't really matter how I had a bit of room on it, then I would go with inches and just kind of make it the easy rough guide, bigger markings. But if I needed to be precise because I was trying to fit a piece of wood inside another piece or something like that, then I would definitely use millimetres. I wouldn't try to get away with it with inches because it's just too messy, just not precise enough. I know you could probably make it more precise and stuff like that, but generally for quick, easy type stuff, with mechanical stuff, I'm assuming that American cars are built on imperial measurements. So if you did start to move towards it, then you're going to be the same as us. You're going to need both sets of tools, double spanners, double Allen keys, double sockets, because you've got to account for imperial and metric. Is it a problem? No. Are the sets expensive for the times when you need the opposite? We don't really get that much imperial anymore. So the amount of use that they get, you don't need an extra expensive set. You can get away with pretty run-of-the-mill stuff. So it's not that big an issue. And I think that we're lucky because we get to use both, because the times when we do use imperial, it's because it's easier for us. It's not necessarily because it's easier to work out or anything like that. It's just purely about convenience. We always go with whichever's easiest. I think that if you're stuck just to metric, then there's a lot of different ways when we use imperial, when we would just not like it. We would prefer to stick to the system that we use, which is a combination of both. And I think that that's what America will end up doing eventually. But as far as critical infrastructure or aircraft or anything involving that sort of stuff, everybody has to use the same system. And judging by that video and the other bits that I've kind of come across along the way, I'm pretty sure that metric is a bit easier and more precise, or at least it appears that way. But the thing that you definitely can't do is try to mix the two, not on the same build, because it's just not going to work out. Not if you're working with stuff like an aircraft or a space shuttle. And I think that the evidence has already been shown for that. At least 2 aircraft that I know of that's gone down because of it. The space shuttle, that's a pretty expensive mistake, because you're talking about the expense of the aircraft blowing up, but you're also talking about the amount of time it took to get to that point. The expense of rebuilding it and costs always going up, and the length of time to redo it. Okay, they might be able to make it better the second time, not just by altering the measurements, but knowing what problems they come up with, they might be able to make a better system, but that's hardly the point. That's not really how we should be doing things. Let me know in the comments what you think, which system you use, no matter what country you're in, and let me know what you think is best and why you think it's better. And if you, like us, use a combination of both, let me know what system you use for what, because I use a combination of both and it's pretty varied on how I use them. So I'm interested to find out the different people, different countries, what it is that you do and how it works best for you. Okay, thank you for watching, and I'll see you next time.